Hello guys, so the given question says the ion that has sp3d2 hybridization for the central atom is. So here we have to check the hybridization of each molecule or ion given. So for the hybridization we have to find the steric number, which is given as S is equal to 1 by 2 valence electron of central atom B plus monovalent atom attached to the central atom minus cationic charge and plus anionic charge. So for the first option, that is ICl4 negative, the steric number come out to be 1 by 2 valence electron of iodine, which is a central atom, which is 7 plus monovalent atom attached to it, which is 4 chlorine, minus there is no cationic charge plus there is one anionic charge. So which comes out to be 6, and for steric number 6 the hybridization is sp3d2. So this is the hybridization of ICl4 minus. Now for the second option, that is ICl2 negative, the steric number S will be equal to 1 by 2 the valence electron of central atom, that is iodine 7 plus monovalent atom attached to the central atom, which is 2, minus cationic charge, there is no cationic charge, plus there is one anionic charge. So the steric number come out to be 5, which means sp3d hybridization. Now for third option, that is Br(F2) minus. Now here the steric number will be equal to 1 by 2. Here central atom is bromine, so which has 7 valence electron plus 2 monovalent atom attached to it. There is no cationic charge and there is one anionic charge. So the steric number come out to be 5, which means sp3d hybridization. Now for the fourth option, that is IF6 negative, the steric number will be equal to 1 by 2 valence electron of central atom, that is iodine 7 plus 6 monovalent atom attached to it. There is no cationic charge and there is one anionic charge. So which comes out to be 7, and for 7 the hybridization is sp3d3. Now, so the hybridization of ICl4 minus is sp3d2, ICl2 minus is sp3d, here also sp3d, and for IF6 minus it is sp3d3. So only option number 1 has sp3d2 hybridization, so option number 1 is correct and all other options are incorrect. I hope you understand. Thank you.
Hello students, let us move to the next question. The size of the isoelectronic species Cl-, that is chloride, Ar, that is argon, and Ca2+, that is calcium, is affected by. The first option says its azimuthal quantum number of valence shell, which is L, and is related to the principal quantum number, and it is given as n-1. In fact, L indicates the type of the orbital. Yes. Now, the second option says its electron interaction in the outer orbitals. The third option says its principal quantum number of the valence shell, that is indicated by n itself, which indicates the shell, and the nuclear charge is the last option. Well, the size of the isoelectronic species. What are isoelectronic species, students? Isoelectronic species are the species with the same number of electrons. So it's not defined that it's an atom, it's an ion, it's a molecule, nothing like that. They are simply species. So they could be ionic in nature or they could be neutral atoms. So for instance, if we take the given data, that is Cl-, Ar, and Ca2+, two of them are ions, one of them is a neutral atom. Now let us list down the number of electrons residing in each of them. It's 18, 18, and 18. Yes. So the same number of electrons Are there? That is the reason, of course, they are called as isoelectronic species, isn't it? What is the number of protons? For chloride, the number of protons is going to be 17, which is the atomic number of chlorine, 18 for argon, and 20 for calcium. So what did I say? These are the number of protons. Yes. Now, the concept says that the size of these electronic species depends upon the nuclear charge. What is it? The nuclear charge. And the nuclear charge is going to depend upon what? The nuclear charge will always depend upon the number of protons, of course. Okay. So greater the number of protons, greater would be the nuclear charge. And greater the nuclear charge, smaller will be the size of a particular species, because the outermost shell, the valence shell, will be pulled more and more inwards. Yeah. So in this case, as we can see, the greatest number of protons is in calcium, right? So the nuclear charge would be the greatest, or you could say the highest, for calcium, isn't it? So the highest nuclear charge will be for calcium. That itself says that it would be having the smallest ionic size, isn't it? And which will be the largest ionic size? Of course, that of chloride. So this will be largest ionic size among these three, isn't it? So if you have understood well, it's definitely the nuclear charge, and that matches with our option number 4. I hope you understood the explanation. Thank you. Hello students, let's start the question. In which of the following processes the bond order has increased and the paramagnetic character has changed to diamagnetic? Now there are 4 systems given over here, 4 processes given over here, and we will have to write down the molecular orbital configuration for each one of them, yes, and then analyze as to where the bond order has increased and where the paramagnetic character has changed to dia. So one by one we'll be dealing with it. So there goes the first conversion, and that is from NO to NO plus. Now NO is going to have a total of 7 plus 8, 15 electrons, okay, and NO plus will be having 15 minus 1, 14 electrons, since it's NO plus, isn't it? Now accordingly we'll be putting up the configurations, yes. So this starts right away with sigma 1s, sigma 2s, yes, and then continues further. So let us do that. Sigma 1s 2, then comes in sigma 1s star 2, then comes sigma 2s2, then sigma 2s star 2. Yes, 8 electrons are done. Now remaining 7 will be accommodated accordingly. So as we can see, the next one is going to be pi 2px is equal to pi 2py. That will accommodate total 4, 2 in each one of them. Okay. Then comes in your sigma 2pz. Okay. So that will accommodate 2 more. Yes. And then comes in your 1 electron, which will get accommodated in the pi star. So 4 plus 4, 8 plus 2, 10, and then pi 2px star is equal to pi 2py star. The total will be equal to 1. In any one of them, it would be residing. Sigma 2 star 2pz would be 0, of course. Okay. Then comes an NO plus. Now everything else remains the same. That means sigma 1s2, sigma star 1s2, then sigma 2s2, then comes in your sigma star 2s2. Yes. Then the next one is going to be pi again. So pi 2px is equal to pi 2py. The total would be 4 electrons once again. Then sigma 2pz would also remain as it is. There's only one change, and that is pi star would be 0. Okay, fine. So now, as you can understand, here the bond order will be equal to the number of electrons in the bonding minus number of electrons in the anti-bonding, isn't it? What is bond order? How is it calculated? It's calculated by subtracting number of bonding orbital electrons minus number of anti-bonding orbital electrons, the whole divided by 2. That is the way you calculate bond order. So the same way we are going to use over here. In bonding, it's 2 plus 2, 4 plus 4, 8 and 2, 10. Total 10 are there. And in anti-bonding, that is the starred ones, 2 plus 2, 4 and 4 plus 1, 5. So that's going to be 5 by 2 and that is equal to 2.5. Yes. Now since there is one unpaired electron, we call it as a paramagnetic character. Okay. Now what about NO plus? So let us calculate for NO plus. Bond order would be equal to 2 plus 2, 4 plus 4, 8 plus 2, 10 minus 2 plus 2, 4 divided by 2. So that would be 6 by 2, which is equal to 3. Yes. And over here, all of them are paired up and hence this would be a diamagnetic substance. Now, as per the question, the desired change has occurred in the very first process itself. So the bond order has also increased as well as there is a change from para to dia. So for sure, option 1 is going to be correct answer. But let us check for the others also. Yes. So the second pair, or otherwise the second process comes into the picture and it is the conversion of N2 to N2 plus. Now 7 electrons in each of the nitrogen atoms makes a total of 14 electrons and this 14 minus 1, that makes it the number of electrons for N2 plus and that is going to be 13 electrons. Yes. So the configuration would be written in a similar manner. Okay. Sigma 1s, sigma 1s star, that is going to be the common one. Okay. If you want, you can chuck it off, but I'm writing it just to make you understand. Okay. So 8 electrons covered up, remaining 6 electrons will be accommodated as follows. So since it's N2, you would be having your pi 2px is equal to pi 2py, the total of 4. Okay. So that makes it 12. And there are 2 more electrons which will get accommodated in sigma 2pz. Done. Next, 1 electron less. That means sigma 2pz1 it is going to be. Yes, isn't it? So let us just complete this. And then comes pi to px is equal to pi to py, the total 4, and then the next orbital would be sigma 2pz1. Done. Now calculate the bond order. The bond order for N2 is going to be 2 plus 2, 4, 4 plus 4, 8 plus 2, 10 minus 2 plus 2, 4. That's it. Divided by 2. So that's 6 divided by 2 and that will be equal to 3 of course. Now since there is no unpaired electron, we call this as a diamagnetic substance. Okay. Now the next part is the bond order calculation for N2 plus. So that's going to be 2 plus 2, 4 plus 4, 8 plus 1, 9. 9 minus 2 plus 2, 4. Yes. And divided by 2. So 9 minus 4 is 5 by 2 and that is 2.5. There is one unpaired electron and hence this is going to be paramagnetic. Now this is definitely not in accordance to what our question is asking. So skip off that process. Next process is going to be your O2 to O2 plus. Yes, what is it? O2 to O2 plus. Now O2, each oxygen atom has 8 electrons each. So 8 plus 8, 16 electrons. And here 16 minus 1, 15 electrons. So let us write down the configurations one by one. Yes. So here we go. This is going to be sigma 1s2, sigma star 1s2, then sigma 2s2, then sigma star 2s2. Yes. Now, next, in case of O2, since it is O2, we would be having sigma 2pz first. So, sigma 2pz2. Yes. So, that makes it 10. Then it would be pi orbitals, that is pi 2px is equal to pi 2py, and that is total number of 4 electrons. And then the remaining ones are going to get accommodated in pi star, of course. So, pi star 2px is equal to pi star 2py and the whole 2. That means 1 electron in each of the pi star orbitals. Yes. Now, similarly, in case of O2 plus, let us write down the configuration first. Sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. Then next is sigma 2pz2. Then we have pi 2px is equal to pi 2py, the whole of 4, and 1 electron less in this case, and that would be pi star 2px is equal to pi star 2py, the whole 1. Done? Okay. So this would be the case, isn't it? And hence in that case, let us calculate the bond order. The bond order is going to be as follows, is equal to 2 plus 2 4 plus 2 6 10. 10 minus 2 plus 2 4 plus 2 6. Yes. So 10 minus 6 divided by 2, that's 4 by 2, and that is going to be 2. And since 1 unpaired electron is in there in each of these pi star orbitals, it would be called as a paramagnetic substance. Yes. And O2 plus, the bond order is going to be 2 plus 2 4 plus 2 6 10 minus 2 plus 2 4 plus 1 5 upon 2. So this becomes 2.5. Though there is an increase in the bond order, the paramagnetic nature is not at all changing. It remains the same because there is 1 unpaired electron still over there. Yes. And next is the conversion of your O2 to O2 2 minus. Yes, O2 to O2 2 minus. That means from 16 electrons, it would be moving to 18 electrons. Now, since we are already having O2's configuration, let us just write down the configuration for O2 2 minus and then proceed with the conclusions. Yes, is that okay? Yeah. So, sigma 1s, sigma star 1s 2. Then we have sigma 2s, and then we have sigma 2s star 2. Yes. Then comes in your sigma 2pz 2. Then comes in your pi 2px is equal to pi 2py, the whole raised to 4. And then there are 2 electrons addition in pi star orbitals. So pi star 2px is equal to pi star 2py, the whole of 4. Yes. Now, in this case, the bond order calculation goes in as follows. It's going to be equal to 2 plus 2. Oh, I forgot to write 2 over here. Sorry for that. Yes, so we continue. So 2 plus 2 4 plus 2 6 and 4 10 minus 2 plus 2 4 plus 4 8 upon 2. So that is going to be 1. And since there are no unpaired electrons, we call this as a diamagnetic substance. Now, though there is a change from para to dia, the bond order is decreasing and not increasing. Hence, we have only and only one process which is showing us the bond order increase, and the change of para to dia is the very first option, and that's the process of conversion of NO to NO+. I hope you understood the explanation. Thank you.